circles, standard form, the basics. So the standard form of a circle is x minus h in parentheses squared plus y minus k in parentheses squared equals r squared, right? So the center, when it's in this form, is hk. And notice there are minus signs in the formula, which means when we come down here and put these things in the center, we change the sign. And the radius is r, the square root of r squared, okay? And the radius is r, okay, just r. So the standard form, we're going to focus on this. Obviously, you could, multiply this out, combine like terms if there were any and that kind of stuff, and square the r squared, and, square the r to get r squared. You could do all kind of stuff to this and have other forms. So we're going to focus just on the standard form as an intro right here on this one, all right? So here, what is the center and the radius? We're going to jump right in here. First, I want to identify h, k, and r, okay? So h, x minus 4 is going to be positive 4, right? Change the sign. That's going to be minus h. So we change it to plus 4. Change the sign here for y minus k, and that's going to be negative 7. It doesn't matter if y's come first or x's come first, but the h goes with the x's, the k goes with the y's, right? When it's in standard form here, this form of the standard form. And then r squared equals what? This is r squared. So r squared is 9. So then what does r equal? R equals 3. And you say, well, Mr. Guest, why don't you put plus or minus? The square root property says, I know. The radius is a distance. What is the radius? Is the distance from the center to a point on the circle. All distances are non-negative. They're not positive, they're non-negative. They're 0 or positive, because how far are you from yourself? You're 0. So they're not positive, they're non-negative. So yes, it's true that it's plus or minus 3, but we're not going to get negative 3 because it's a distance. So the radius is 3, r is 3, and the center is 4 comma negative 7. So again, I want to identify h, k, and r. H here is 11, and then k is 13, right? The opposite of that's 11 and 13. And then r squared, this time is a fraction. It's 100 over 49. But look, how do you square root, right, of that? If you take the square root of 100 over 49, it's the square root of 100 over the square root of 49. So it's going to be 10 over 7. Notice I'm not showing the square root, because then I would have to get into absolute values and pluses or minuses, and square root property says plus or minus if we just go straight to it. But again, we're not interested in the negative value here because r is a distance. So my radius is 10 over 7, and my center is 11, 13. So again, technically, this plus or minus is here. But we don't need it because we're talking about a radius. So we assume that, or not assume, we know that a distance is positive or 0. It's non-negative. So then I just can take the square root of 110 over the square root of 49, 7, and I don't need to worry about negatives or anything like that. All right? So what's h, k, and r here? So again, I'm just trying to give you crazy stuff. I mean, h is negative 1/2, right? Because you change it from positive. The next one is the square root of 5. I mean, who has a radical there? But I just put one there for fun, okay? Right? So much fun math is, right? R squared is equal to 49. So then what does r equal? Well, it's 7. R equals 7. So my radius is 7, and my center is negative 1/2 square root of 5. Yeah, have fun graphing that one, right? So, but again, 1/2 is 0.5, so that's negative 0.5, and the square root of 5, square root of 4 is 2. So it's a little bit bigger than 2. It's 2 point something, 2.1, 2.2. I don't know, just something. It's not 2.9, right? Because the square root of 9 is 3, so it's not quite that far. It's much closer to 2, you'd think. So whatever it happens to be. The next one, what is h? What is k? And here I put, quote unquote, a trick here. So h is 1, but look, what's attached to the y? Nothing. But what number means nothing? 0. That's the same thing as y minus 0 squared. Well, you simplify that to y, so you get y squared. So 0 for k. And then r squared is 11. Wait a minute, r equals what? The square root of 11. The square root, is that okay? Yes, it can be a square root. So square root of 11 for the radius, and the center is 1, 0. And I don't like either one of my square root symbols. I don't like either one of my radical signs here. We're going to fix that. We're going to fix that mess. So this is a great example of why you use something that can be erased well. And in my opinion, erasable pens and ink don't work very well. So that's why you always use a pencil in math for a test or anything. That way you can erase it. So if you write an ugly radical sign like I did, and if you write like I do, you write lots of ugly things. I can barely write. You can't read it. So I went back and changed my radicals to make them look a little bit better, more like a radical. All right. So the square root of 11 is r, and then 1, 0 is the center. What if I wanted to go the other direction and I wanted to find the standard form of the circle when I have h, k, and r? So r equals 17, h is 9, and k is negative 121. Okay. So then x minus h squared, and that looks like a capital X. Let me just fix it. I just messed it all up. X minus h squared plus y minus k squared equals r squared. I'm not sure what that's supposed to be. R squared. I'm trying to write a number or something. So then x minus 9 squared plus y minus 121 is plus 121 squared equals 17 squared. So I have an answer box down here. That's what this is. So I could write the whole thing down. I'm just going to do this. X minus 9 squared plus y plus 121 squared equals 17 squared is 289. All right. So, and look, if you wanted to, you come out here and say, okay, let me come out here in a thought cloud and go 17 squared is 289. So right here, I could just write 289 from the start and box it, whatever. All right. Because that's really the only work you're doing there is going through and squaring the 17. We're doing standard form, so we're not foiling those things out and trying to figure out what they are. All right. So then again, I went with some crazy stuff here, trying to make it different and whatever. So this is h, this is k. So my h is negative 5/8, and there it is, taking away this. So let me do this here real quick. And k is 2, and r is the square root of 13, right? This is my r. So then what is r squared? If I just want to go ahead and find it, I could say that's going to be 13, right? I take this and square it and take this and square it, and I get 13, right? So x minus h squared minus y minus k squared equals r squared. So x plus 5/8 squared minus, not minus, did I leave that off or did it? I may have just messed that up. That's supposed to be a plus sign. Okay? The formula is plus. So I don't know if I did it and it took it away. I don't think that's what happened here, but it does take it away sometimes, but I think I just left that off. That's supposed to be a plus. So plus, and then y minus k is minus 2 squared equals, see, here I have r squared, and I found it right here, so I'm just going to bring the 13 down instead of writing square root of 13 squared. I could do that, but I'm going to go just through and say, okay, this is actually just 13. So there's my final answer. But if I have an answer box, I always want to write my answer in my answer box. So if your teacher has place for the answer, put the answer in the place that they have. They're grading. You're taking one test. They're grading a bunch of tests. Okay, so from that perspective, they can be a lot more efficient and great if the answers are all in the same place. That's why I do it. I put an answer box and say, put your answers in there, because then I know exactly where to look for that final answer. And if something is wrong, if something is amiss, then I go back and look at your work and say, okay, where did you go wrong? So x plus 5/8 parentheses squared plus y minus 2 in parentheses squared equals 13 is the equation of that circle in standard form. And again here I just went crazy. 0 in the cube, negative the cube root of 5, really? So this is h, this is k, this is r. So my h is 0, my k is the, not the cube root, it's the negative cube root. Negative cube root of 5. And then r equals 7. So what is r squared? It's 49, right? So x minus h squared plus y minus k squared equals r squared. So x minus 0 squared plus y plus the cube root of 5 squared equals 49. That's what r squared is, right? So then really I don't want x minus 0. I want to simplify that to x squared, right? So let me just not slash through that. But anyway, that becomes x. So x squared plus y plus the cube root of 5 squared equals 49. And there's your final answer. And again, even though I boxed it, even though it's a lot to write down, even though it's I'm taking one test. So for my teacher and for the direction's sake, that probably on their test says put your answer in the answer box, if they have something like that, do that. X squared plus and then y plus the cube root of 5 in parentheses squared equals 49. Equals 49. And there's your equation for that line. So the center and the radius, and then graph it. So here, this is h equals 1, right? The opposite of that number. K equals -1, so my center is 1, -1. So my center is 1, -1. So then over here, 1, -1 is right here. That's the center. So that typically we don't plot a point that's not on our graph, but we're graphing a circle. We need some reference point so that we have the bullseye, so to speak. The bullseye is plotted there. And then from that point, what about my radius? My radius is going to be what? Well, this r squared is 16, so r equals what? 4, right? Square root of that's 4. And again, we're not worried about plus or minus in the radius sake because the radius is a distance, and distances are non-negative. So they cannot be negative. They're not always positive, they're non-negative. So 4 for the radius. We're going to go 1, 2, 3, 4 up. 1, 2, 3, 4 up. Then we're going to do what? 1, 2, 3, 4 down. We're going to go 1, 2, 3, 4 to the right. So we went down 4, right 4, up 4, and then we're going to go left 1, 2, 3, 4. So we went 4 in every direction that we have on the grid here. We don't want to go at an angle because we don't really know where that is. So then I want to connect this as a circle. And so what happens is when students graph these, it trips me out. It's like they're the biggest baseball fans ever. They got a diamond here. Okay? So you really have to I think you have to exaggerate it when I draw it. Okay? So I literally start straight up from this point and end straight to the side on this point. And I really over-exaggerated that, so I'm going to fix it. And then I'm going to come over here and keep going and go straight out and straight down. And I just still messed that up. So, I mean, it's not going to be perfect. It's a sketch. Okay? And this place is it's a weird place on the board, so it's not the easiest place for me to draw my circle. Should have made my grid higher. All right, so there's my circle. Again, that's a sketch. I'm not going to count off if it's circular, but if it's a diamond, with sharp edges almost, then I'm going to count off. Right? So there it is. All right, and so just make sure how particular your instructor, teacher, professor is going to be about that or whatever. But most of us know it's a sketch, and if it's close, I mean, if you draw something like this as a circle, that's not a circle, okay? But, close. The center is 0. Look, here you don't even have to find it. The center is 0, -2, and the radius is 3. So 0, -2, 0 on the x, down 2. There's the center. And then from that point, we go up 3. 1, 2, 3. We go down 3. We go right 3. And we go left 3. And there's our 4 points that we have on our circle. So then when we get ready to graph this, we just come in here and do that, okay? So, and that one looks pretty bad, okay? So I'm actually going to fix it. It's pretty bad. It's pretty bad all around. So we're gonna, but it was close enough. I wasn't gonna. That wasn't one that you would have lost any points on my test there. Okay, so it's just I'm putting this on video for you, so I want it to be a little better. And although this one kind of looks teardrop, kind of over here it kind of looks like it's coming in as a teardrop. But anyway, it's close enough. It's a sketch of a circle. I'm going to leave it that way just because again, that one that bottom corner there's pretty bad. Actually, I think I'm going to fix that. It just bothered me. Okay. See, look how bad that is. So let's try this here. Let's try this one more time, and whatever it is, I'm probably going to leave it this time. Okay, so there it is. It's not perfect again, but that's my whole point. Yeah, I'm fixing it. I could keep doing this, And I even did an extra one there just to show you, hey, you know what, I could sit there and try to fix it 14 more times, and it's still going to be approximate. It's not going to be a perfect circle. So it's okay. So then here, center is negative 3, 1. So we go negative 3 on the x and up 1 on the y. There's the center. From that point, the radius is 2. We go up 2. We go down 2. We go left 2. And right 2. And those are all points on my circle. So then we come up here and we that's not good. I can already tell that's not good. All right, and again, that's not great, but it's circular-esque. All right, so there's my circle. Plot your center, your bullseye, so to speak. Right. So then, and then you have your up, down, right, and left, because on a grid, those are the easiest ways to go 2 units or whatnot. So I hope this helps with standard forms of circles.